Okay, good morning, students. Last time we have discussed with you the structure of the glucose. In the how we establish the structure of glucose is an important question. As I said, questions will be asked. For example, the question which was given to the student question one, how which chemical which reaction proves that glucose contains glucose contains six carbons in straight chain. For example, if this question is given, this question was given students, 1 mark question. What is the answer, student? What is the answer for this question, students? What is the answer? This is how the questions come in the papers.
Yes, sir.
So when we teach you, we have to tell you what type of questions are coming, how they are coming, students. Which reaction was it? What is our answer, students? We know the answer of this. We have already given. What is our answer for this question, students? What was the answer of this question? Which reaction was done in order to prove that glucose contains straight chain six carbons? What was that? What was done? Glucose was heated with. Glucose is heated with HI. What was the result? What was the result, students? What we are saying, you have this glucose. Students, in the exam, what I am saying, what was obtained? CH3, CH2, CH2, CH2. How many carbon? 1, 2, 3, 4, 5, and 6. Normal hexane. This reaction proves that glucose has 6 carbons arranged in straight chain. Yes or no? Yes or no? Tell me.
Yes, sir. Yes, sir.
So this is how we have to write in the paper, students. Question will be asked in the exam, then we have to answer the question, students. Say question, and then they gave you question that glucose is oxidized with bromine water. Write the product. Write the reaction. What we are saying in the exam, students, they are saying glucose, bromine water. Now you have to write the product. 1 mark question. What is the answer? What is the answer coming? When glucose is reacted with bromine water, what happens, student? Keep your energy straight away high. We have to think, we have to revise, we have to answer questions in the paper, students.
Yes, sir.
Unless we will think, we will not answer anything. What we are studying otherwise, tell me. Course finishing is not a problem. NCRT book is there.
Yes,
With
sir.
all
Yes,
the
sir.
students. And we have to learn each and everything, student. What is the formula, what we were getting, student? When bromine water will oxidize, which functional group is oxidized by bromine water? It is a mild oxidizing agent.
Okay, sir.
It is mild oxidizing agent, student. Now we have to write the product, student, in the exam. What product you wrote? CHO group will be oxidized.
Okay.
Which group? CHO group will be oxidized. And what will be the product, student, in the glucose? Then you know what glucose we are talking about. This, what is the name of this? What is the name of this? We told you, student. Which acid was produced? Gluconic acid.
Yes, sir. Gluconic acid.
Okay. See that in the exam we have to write the reaction, student. We have to write the reaction. It is a mild oxidizing agent, CH. And if a question is given that glucose is reacted with concentrated nitric acid, then write the product. Again, this question is coming now. What is our answer, student? What is our answer? I give you 1 minute to answer the question. Be careful with me. Check your notes. Whatever we do last time, you have to revise. Revise, student. It is very important, or we will forget the answers. How will we write the answers in the paper? You will write the answers in the paper. These questions are coming, which I am talking about. What happens? What is the concentrated nitric acid? Is a strong oxidizing agent.
Oxidizing agent. Yes, sir.
So what it will do? It will oxidize, students, CHO group as well as the primary alcoholic group. Then what is the product? What is the product? This will also become COH. This will also become COH. What is the name of that, student? What do you get? So I can write in the paper like this. CHOH. This is 4 times. And CO.
Yes, sir.
What is the name of this compound? What acid I told you?
Sir, glucose.
Succaric acid.
Okay, saccharols.
Bus, that's all. I have to write this. I will get 1 mark. If I don't write this, 0 marks.
Zero marks.
Nothing else beyond that. I hope you understand how to answer a question, students.
Yes, sir.
You don't have to write more than one line or 1 word. That's the end of the answer. And you will get full marks if you know it. And if you do mistake, then there will be no mark. Every time I'm saying that you have to be careful, student. You have to keep on revising the things, or we will forget it. Further, he says that glucose, when glucose is reacted with acetic anhydride, student, what happens? I'm giving another reaction. Glucose is reacted with CH3, CO twice O. You have to write the product. This is acetic anhydride. What product we told you, student? What product was obtained when glucose was reacted with acetic anhydride, students? This is how we establish the structure of the glucose. Because they cannot ask you all the complete structure of glucose. Let me tell you, one of this will be asked. And usually that carries 1 mark question. So they will say glucose is reacted with acetic anhydride, write the product. You know
Yes,
what
sir.
we formed? Pentaacetate. Pentaacetate, student, because one OH group forms acetylation. This is an example of acetylation, student, of alcohols, OH groups. And then what is the result? Where are the OH groups, student? How many we have told you? OH group. This 4 and 1, 5 OH groups are there. So they will all form S. So what is the product, student? If I write CH students, then I can write O, C double bond O, CH3. This is 4 times.
Yes, sir.
And CH, in the last you have CH2, O, CO, CH3. See 4 and 1, 5 times. You can see that this is a pentaacetate.
Yes, sir.
What is acetate? CH3CO group, COO. This is acetate group, pentaacetate. That's all we have to write this. So this is just to tell you that the structure of glucose is very important. One of the questions can be produced. After this, student, the Fisher proposed a configuration for D plus glucose, who gave the special position of arrangement of OH groups in the glucose Fisher. So that we have, here is the formula, student, Fisher projection formula. What I'm saying, Fisher projection formula. This is the formula which was given by Fisher after experimental evidence was available. No formula can be written without experiments. Let me tell you, I cannot write any formula.
Yeah,
The
obviously, sir.
formula must be having evidences. What evidences we do in chemistry, chemical reactions we do, experiments we are doing. From that data, student, we say, okay, this is the configuration of D plus glucose, student, CHO. This OH, see the position. This is my carbon 1, carbon 2, carbon 3, 4, 5, and 6, students. This is a primary carbon. No, this is not an asymmetric carbon. There are 1, 2, 3, 4 asymmetric carbons. How many asymmetric carbons are there in glucose? Four asymmetric carbons. This question, any question can be there. How many asymmetric carbon? Four. Number two, number three, number four, number five. This is carbon, this is carbon, carbon, carbon. And what is the configuration of OH? You can see this OH is on the right, this is on the left, then right. So how do you remember this? How do you remember the structure of glucose? Short form, I remember like this.
Yes, sir.
This is the short form of this. This group is CHO on the top. And this means OH on the right side. This means OH on the left side, student. And these OH are on the right side, student. And the last one is always CH2OH. And then balanced by H. This is how I write the structure of glucose. This will be H. And you can see that whether it is a D form or L form, whether it is a D form or L form, the question is given that this glucose is D or L. How do you decide D or L? The last or the lowest asymmetric carbon, which is the lowest asymmetric carbon in this?
Yes, obviously.
This one, carbon 5. Lowest asymmetric carbon is, student, carbon number 5. Is carbon number 5. If the OH is on the right hand side, what do you call this? We told you last time, this configuration. How do we write? If this OH is on the right hand side, we call this as D or L.
Yes, sir.
If the position of OH group of the lowest asymmetric carbon is to the right, what do we call it? Which configuration, D or L?
Sir, it will be D, sir, D.
D. We told you with glyceraldehyde, this is the glyceraldehyde. OH on the right is called D. This is D. And same thing we compare the last. This is the asymmetric carbon, which is the lowest, which we have shown here, student. When it is on the right side, it is a D, D plus glucose. This is a Fisher projection of D plus glucose.
Yes, sir.
If I write L plus glucose, then this OH will go on the left hand side. OH will become left, then it will become L glucose. L glucose. So this is D glucose, not L glucose. L glucose means this OH position will be reversed, student. It will go to the left side. It will go to the left side, student, not to the right side. So if I draw a mirror image of this, then there will be an enantiomer, which we will say L form of the glucose. So students, this is how the structure of glucose and Fisher projection of the glucose is given. Now the question is, students, this is called open chain. This is called open chain structure of glucose. Open chain structure of glucose. Now the problem started, student. What problems were faced? According to this open chain structure of glucose, you have CHO group. What do you have? CHO group. Can you see that this contains
CHO group? Yes, sir.
CHO group?
Yes, sir.
Is present at number 1 position, student. So there is a free available CHO group.
Yes, sir.
And then they were studying the reactions of the glucose. It was found there are many reactions which glucose does not give, which every aldehyde gives. And when we studied the chapter of aldehyde and ketone, students, we have told you that aldehydes or ketones give Schiff's test, react with sodium bisulphite to form addition product. They react with ammonia to form addition products. But when they reacted glucose with Schiff, with ammonia derivative, students, with amines, this test was not given by glucose. Similarly, when reacted with sodium bisulphite, the addition product was not obtained by the glucose.
Yes,
Further,
sir.
they found the pentaacetate of glucose does not react with hydroxylamine. This is an important point, student, here, that despite the fact, what I am saying, students, what we are saying, that glucose, as you can see, has a CHO group. ठीक है? But it did not give the following reactions. But it did not, student, when the test was done, it did not give Schiff's test, which is given by aldehyde, which is given by.
Yes, sir.
Then glucose did not form, student, sodium bisulphite addition product. Sodium hydrogen sulfide, what is that? NaHSO3 addition product. This product was not formed by glucose. And the pentaacetate of glucose, students, did not form, did not react with,
That with.
hydroxylamine, NH2.
Yes, sir.
What it means, student? These reactions are the typical reactions of the carbonyl compounds. What we told you in the carbonyl compounds, these are the carbonyl compounds. And they give all these reactions, students. Carbonyl compounds give these reactions, but this is not giving this reaction.
Yes, sir.
Glucose does not give 2,4-DNP test, dinitrophenylhydrazine. So that means, students, these reactions which should be given by aldehyde are absent in glucose.
Yes, sir.
Then how will we explain? The only thing is that in glucose, the CHO group is not free. What we are saying, the CH group is not free. It is bonded somewhere else. It is bonded somewhere else, students. Therefore, it will not give these tests. These tests are not given. Further, it was found that glucose exists in two crystalline forms. What
Yes,
was
sir.
glucose, students, exists in two crystalline forms, students. And they were able to isolate alpha and beta glucose. One is called alpha form, other is called beta form, students. They have different melting points, students. They have different melting points. And this behavior could not be explained by the open chain structure of glucose. So, if this is my open chain structure of glucose, this is the open chain structure, which this is my Fisher projection of the open chain structure of glucose. This contains CHO group, but it is not giving the reactions of the CHO group, student. Then how will we answer this question? And instead of one, there are two forms of the glucose. One is alpha, other is beta. As we
Beta.
say,
Yes, sir.
there are two crystalline forms of glucose, alpha and beta. Students, alpha form has a melting point 419 Kelvin, crystallizes from a concentrated solution of glucose at 303 Kelvin, and beta form melting point of 423 Kelvin,
Yes, sir.
crystallizes from hot and saturated aqua solution at 371 Kelvin. So we cannot explain these reactions by the open chain structure of glucose. This is what I have written here. This is the open chain structure of glucose. Open chain. This is called the open
Chain.
chain structure of glucose. I cannot explain these reactions. I cannot explain the existence of alpha and beta forms of glucose. Now, how do we, what is proposed, student, then? What is proposed? This behavior cannot be explained by open chain structure. What we are saying, this behavior, this chemical reaction, or I say this behavior, cannot be explained by open chain structure of glucose.
Yes, sir.
So the real problem now. Then what happens, student? Therefore, student, what they suggested, what it was proposed, what was proposed and has been experimentally verified later on, student,
Mm.
that glucose forms a cyclic ring. So what
Yes,
we
sir.
are saying, cyclic structure of the glucose. The glucose, this behavior cannot be explained by the open chain, and what was proposed, student, what they proposed is a cyclic structure of glucose. What do you mean by cyclic structure? Because what we are saying, this behavior cannot be explained, therefore we propose a cyclic structure of glucose. What do you mean by cyclic structure of glucose?
Yes, sir.
What happens is the this is my glucose. The carbon number 5, what we are saying, student, that this and this OH group forms a bond with the carbon of this, and this there will be oxygen. We will tell you what reaction is this. This OH group is going to attack this carbon which is here,
Yes, sir.
and a bond will be formed inside this. So what we saying that we are aware of the formation of hemiacetal by the carbonyl compound, student. What you already know. This is our aldehyde. You have been told a reaction called hemiacetal formation, student. Hemiacetal formation. That this, you know what happens. This reaction we have discussed in aldehyde group when we react this with alcohols. What happens? You know that this OR dash, this will attack this carbon and form a bond with this carbon. This will form a bond with this carbon, student. What we are going to get? RH, OH and OR dash. What do we call this as? Hemiacetal. Hemiacetal. Now the same thing will happen here because there is a OH group. OH groups are present and CHO group is present within the molecule.
Yes, sir.
Here, there are two different molecules, but in this case, what will happen, student? This OH group will attack this carbon, which is electrophilic, and there will be a what we call as a hemiacetal formation, and this results in the formation of a here cyclic hemiacetal in the case of the glucose is formed. So there is a
Yes, sir.
cyclic hemiacetal structure. Therefore, glucose forms is not an open chain, student. It forms a ring. And what type of ring can be formed, students? There are so many OH groups. Why
Yes, sir.
it doesn't form a ring? Why it doesn't form a ring? Why it doesn't? Or which one will form the ring? It depends on the stability of the ring, student. Stability of the ring. And we know that Six-membered rings are more stable.
Yes, sir.
Six-membered rings are stable, students. Therefore, glucose will form a six-membered ring. It also forms a five-membered ring, but six-membered ring is more stable. Lower membered rings are unstable and there is a lot of angle strain.
Okay, sir.
Not possible to form. Therefore, the fifth OH of the fifth carbon student forms a cyclic hemiacetal with the carbon number one, which is CHO group. And glucose, that is what we call as cyclic structure of the glucose. Cyclic structure of the glucose. Therefore, we are saying the glucose exists in cyclic form. When it will be existing in the cyclic form, then what will happen? This free CHO group is not available. This free CHO group will not be available, students. And when this CHO group is not available, then glucose will not give the reactions of the aldehyde group. All these reactions which we are saying, aldehyde group, it does not give Schiff's test, does not react with sodium bisulphite, pentaacetate of glucose does not react with hydroxylamine, student. So
Yes,
this
sir.
reaction can only be explained if glucose undergoes cyclization,
Okay.
and this will happen with carbon 5 and carbon 1. So now, students, we are saying that here we are saying this, you can see a ring has been formed. Cyclic structure of glucose, student. How will we write? Now we be careful what I'm saying. This is my carbon 1, 2, 3, 4, 5, and 6. So this is the fifth carbon, student. This is going to get attached at this point. Then what will happen? This will become O minus, this will become OH, and you will get, students, when this will attack OH, what will happen? You can see cyclic ring will be formed, and this is an oxide. So this is a cyclic hemiacetal, which was also obtained in the case of aldehydes when they reacted with alcohol, students.
Yes, sir.
So this is a carbonyl group now which has been converted into OH group. There is no double bond. There is no double bond here. You can see cyclic ring has been formed. This is carbon 1 and carbon 5. 1 carbon, 2, 3, 4, and fifth carbon.
Yes, sir.
Between carbon 1 and carbon 5, a cyclic ring has been formed. As you can see, oxygen in between them. And then the carbon number 1, student, carbon number 1 will have OH group. This carbon has become, this was sp2 hybridized. This carbon has a double bond. It is sp2 hybridized.
Okay, sir.
But when the ring is formed, the double bond is not there. And you can see this carbon has got now 4 groups attached to it. This is sp3 hybridized carbon. Now there are two possibilities, students, in this. Two isomers will exist depending on, because you have created an asymmetric carbon more. How many asymmetric carbons were there in glucose? Now this has introduced one more asymmetric carbon in the glucose
Okay, sir.
at number 1 position. At number 1 position was not. So one more carbon, asymmetric carbon created. Number 1
Yes,
was
sir.
not an asymmetric carbon in the case of glucose. But here you can see what has happened. This number 1 has become asymmetric. Therefore, there are two possibilities. This OH group can be on the right or can be left. When OH group of carbon 1 is in the right position, student, we call this as alpha D plus glucose. And when OH group is on the left hand side, this is called beta D plus glucose. Here we have shown the structures of the two. That is why we said na glucose exists in two crystalline forms. These are the
Yes, sir.
alpha and beta form. The alpha form has a melting point 419 Kelvin, crystallizes from concentrated solution of glucose at 303 Kelvin, and beta form has a melting point of 423 Kelvin, students. The melting point of beta is 423. So one of this is alpha, one of this is beta. There are two forms now, as we have seen. The only difference in the position of carbon 1. If in the position carbon 1 OH group is on the right side, student, that is called alpha.
Yes, sir.
This is my alpha D. This is our alpha D plus glucose, students. The OH group is on the right side in carbon 1. You can see that. Number 1 carbon. This is my number 1 carbon.
Yes, sir.
So which form will exist, students? Glucose exists in two forms, and therefore as soon as you put glucose in water, student, what we are saying, there is a, these forms are interconvertible.
Okay, sir.
Most of it is in the cyclic form, but a small amount of open chain is present. There is an equilibrium. There is an equilibrium between open and cyclic form, students, and this maximum is the cyclic form of glucose, and very small amount of open chain form exists. These are the structures which we have drawn. First you draw the structure, then we will tell you more information about this. You can draw the structure, students.
Yes, sir. Yes, sir. Obviously.
Therefore, glucose exists in cyclic form. They will ask a question, what reactions were not shown by the open chain form of glucose? And then we have to propose a cyclic form of glucose, which has been verified experimentally also, that glucose forms a cyclic structure. Glucose forms a cyclic structure, students.
Yes, sir.
Can I proceed further, or you are doing anything here?
2 minutes, I get the copying.
Copy it. No hurry. You can see that where the projection is coming from.
Yes, sir. Copied.
Okay, what I am saying, student, what I'm saying, very important question. That the open chain structure of glucose could not explain certain properties. ठीक है?
Yes, sir.
Explain which properties? That there was no formation of sodium bisulphite addition product. There was no formation of oxime by the hydroxylamine. Ammonia 2,4 DNP test was not given. All this reaction indicated that the CHO group is not free in glucose. This group is not free.
Yes, sir.
Therefore, it was proposed, what they proposed, cyclic structure of glucose.
Okay, sir.
They proposed a cyclic structure of glucose. So it is said that what will happen, since we are aware that aldehydes and ketones react with alcohols to form hemiacetals. So they said ki, what they proposed, student, that there is a hemiacetal type of reaction which takes place within the glucose. So the OH groups, the fifth carbon OH group adds to student carbonyl aldehyde group of the glucose, and this
Yes, sir.
results in the formation of a cyclic ring. And since this will be a six-membered ring, students, this ring is six-membered, and six-membered rings are stable. Glucose also form a five-membered ring, but that is less stable than six-membered. For our course, we are only telling you six-membered ring.
Okay, sir.
Because there are so many OH groups present in the glucose. We said fifth OH group. If the fourth OH group will form student hemiacetal, then the ring will be five-membered. Five-membered. And five-membered ring is also known for the glucose, we want to tell you.
Yes, sir.
Therefore, what type of reaction we are using? You have used this type of reaction, student. If this is my aldehyde group, this is my aldehyde group, student. Any group is present, then you know what happens in this at this carbon. This carbon is electrophilic, student, positive, this is negative. And alcohols, what they did, this was negative, minus, they attack at this, and the product was, student, what was the product? OHOR dash. What is this called? Hemiacetal.
Okay, sir.
This is a reaction of aldehyde and ketone, student. Here also there is a, we can say that the CHO group can form a cyclic hemiacetal with the OH. Here it is a, what they are forming, cyclic hemiacetal.
Yes, sir.
Cyclic hemiacetal formation, which takes place in the glucose. Now because now there are two possibilities, there are two isomers, student, which are stereoisomers. As you can see that I have drawn two structures now when cyclization takes place, because you are going from sp2 to sp3 hybridization. The OH could be on the right side or OH could be on the left hand side
Okay, sir.
at carbon 1. When OH is at the right side, it is called alpha D plus glucose. Alpha D plus glucose has a specific rotation which can be observed with polarimeter, students. This value will be different from this. Their specific rotation is different, alpha and beta forms. So there is a difference only. What is the difference in alpha and beta form? Only at C1 configuration, students. The C1
Yes, sir.
OH group on the right side is called alpha. The C1 OH group on the left side is called beta. And such isomers are stereoisomers. And these stereoisomers are known as, student, anomers. But instead of one, we have now two forms of the glucose. How many forms of the glucose you are having? Instead of one, two forms of the glucose. They are called, student, anomers. Question has been asked in the paper, what are anomers? This question was given in the paper, student, what are anomers? What you are saying? There are two glucose, alpha and beta. In alpha, the carbon 1 OH is on the right hand side. And in beta, the carbon 1 OH is in the left hand side, student. Therefore, they are stereoisomers. And these are called anomers. So what is the definition of anomer? Tell me, what is the definition of anomer, students? Stereoisomers that differ in the configuration at C1
Yes, sir.
is called anomers.
Anomer.
This question has been asked in the paper, what are anomers? Further, student, the structure which I have shown earlier, straight chain, that was proposed given by Fischer. That is called Fischer projection formula of glucose. Haworth given six-membered ring formula, because glucose cyclic formula is nothing but a six-membered ring. When carbon 5 of OH group will form a cyclic hemiacetal with carbon 1, how many sides will be there in the ring? 6. So six-membered ring is formed. What is the size of the ring? Ring 6.
Yes, sir.
Third ring is formed, student. And in chemistry, student, there is a compound which is six-membered ring with oxygen present in it. Because in the cyclic structure, what you have seen, there is oxygen. See the oxygen? This oxygen. Hemiacetal has been formed, student. This is oxygen. This is the fifth carbon which is attacking this carbon. So, students, this six-membered ring structure has been proposed by Haworth. They are called Haworth structure. How do we write Haworth structure, student? There are two, because how many forms of glucose I told you? Two, alpha and beta. They have different melting points. They have different specific rotation in the polarimeter because they are optically active compounds. Their specific rotation is different, students. How to draw this type of structure, student? This is a pyran. Pyran is a six-membered ring in the organic compounds, and there is a oxygen. You can see the oxygen in the pyran, student. Six-membered ring with oxygen is called pyran. I have drawn the structure of pyran here. So when we draw such structures which were proposed by Haworth, they are called glucopyranos. Why we call them glucopyranos, students? Why do we call that glucopyranos? Pyranos comes from pyran, six-membered ring with one oxygen. So what I do, students, I draw six-membered ring. This is my six-membered ring, and there is oxygen here. Can you see that? How many sides are there? Six. Six, students.
Yes, sir.
And what is the open form of glucose? We told you open form of glucose. This was our CHOH. And I said we have to remember the positions of the OH groups. In the first case, OH was on the right. In the second case, OH was on the left. Third, OH was right, OH right. Tell me, is it the correct Fisher formula I have shown?
Yes, sir.
And what happened? Carbon 5 now. This is fifth carbon. And this is carbon 1, students. Here, their cyclization takes place.
Yes, sir.
Hemiacetal cyclization reaction. So ring will be formed between 1 and 5, 6 members.
Yes, sir.
To draw this, student, what we do is you make a ring like this. We will have to draw it once or two times, then it will become easy. This is a, which ring is this? This is like pyran. Pyran is a six-membered ring with oxygen atom. Now, what I will do? These are the sides of the hexagon. These are above, this is below. You can see that the OH group, students, OH group which is coming on the right hand side is written below. Below. This is after cyclization, students. What structure we have given? This is not the cyclic structure. We have shown it. This is the cyclic structure.
Yes, sir.
Here OH is on the right hand side. In the alpha form, OH is on the right side. Carbon 1 OH right side, carbon 2 OH also on the right hand side, students. So what do we do? Those which are in the right hand side are written below, and those which are on the left hand side, student, it is written on the top. And then what happens? CH2OH, balanced by hydrogens everywhere. So this becomes the structure of student Haworth. This is called the Haworth structure. Haworth structure.
Yes, sir.
And this is OH group on the lower side is called alpha D plus Glucopyranose. Why pyranose? Because this pyran has six-membered ring with one oxygen. That name has been derived from here, students. So you can see the structure, how we are writing. So 1, 2, this will become H, then this will become H. This is already C, H2OH. So 1, 2, 3, 4, 5. Like this, we number these carbons, student, number these carbons. This is the alpha form. If you want beta, the only thing you do is shift this position of the OH. This OH will be on top and this will become lower. But I
Okay,
will
sir.
do
Question top.
everything same. This OH will go on the top and this will come here. So say carbon 1, carbon 2, 3, 4, 5 students, and this is my sixth carbon. So now this is the Haworth structure of glucose. If you want beta, you draw the same, but this OH on the top and H on the lower side. Okay, you draw these two
Yes.
Haworth structure. Sometimes in the paper they ask the student draw the Haworth structure of D plus glucose. This question was asked, draw the Haworth structure of D plus glucose, students. After you are finished, you will tell me, then I will proceed further.
Yes, 2 minutes. Two minutes of copying.
So the cyclic structure looks like this, student. 1, 2, 3.
Yes, sir.
How many carbons are there? 5 and 6. Okay? Carbon 1, carbon 2, carbon 3, 4, 5 and 6 students. And this is CH2OH, no problem. Now this carbon 1, which was CHO group, is forming, student, cyclic hemiacetal. So how do we write forming cyclic acetal? With which carbon it will form? With fifth carbon. This is the fifth carbon. See the fifth carbon? And in the first case, you see OH on the right side. Second was already on the right side. Third was OH on the left side, and this was on the right side. Then this will be hydrogen, this will be hydrogen, this will be hydrogen, this will be hydrogen. This is the cyclic structure which I have translated into this form. This OH group is on the right side at C1. This is called alpha form of glucose. OH group on the right, see C1. At C1, OH is on the right side. This is alpha form.
Yes, sir.
And if I make OH on the left side, students, that will be which form of the glucose? Beta form of the glucose. That means I am saying 1, 2, 3, 4, 5. We have to learn it, student, practice. We have to do little bit of practice, then only we will be able to do it. This is my carbon 1. Okay, and this is my carbon 5, student. Then where is the ring? Between 1 and 5. Which
Yes, sir.
membered
Yes,
ring
sir.
will be this? 1, 2, 3, 4, 5, 6. 6-membered ring. This is a 6-membered ring. Now, if this OH, student, if this OH is on the left hand side, okay, then what are the other positions? Same. Other positions same. I am saying I am not changing the other position, student. Then this will be hydrogen. This will be hydrogen. This will be hydrogen. What is this? OH on the left hand side. This is the beta form of glucose. Okay, there are two forms, alpha and beta. And how will I write the Haworth structure of this? What I said, draw a pyran ring.
Yes, sir.
How do I say draw this? What is a pyran ring? You are drawing like this, 6-membered ring. Can you draw it? Then I am putting these lines. This is the top, this is the bottom. The groups which are on the right hand side, student, they come lowercase, and the one which are on the left, they come on the top. They come on the top, and the CH2OH comes here. That is the sixth carbon, because this is my carbon 1, 2, 3, 4, and 5, and this is the
Yes,
sixth.
sir.
So I said only difference in alpha and beta form. Beta form will be, if I draw the Haworth structure, will be only here OH is on the lower, here OH will be on the upper, because it is on the left side. The left side are written upper. This is the right side, it will come lower. This is on the left hand side, it will come top. This will come lower, and then put hydrogens. This will be hydrogen, 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 hydrogen. This is CH2H. This is the beta form, students, of beta D plus glucopyranose. This is a way to learn how to draw the Haworth structure, because in the paper, student, this question was asked, draw the Haworth structure of D plus glucose. ठीक है? We have to learn it. One mark question only. One mark question. Here I have shown that how do we simplify the situation. देखो, you can see it. This is the aldehyde group. 1, 2,
Yes, sir.
3, 4, 5, 6 carbons. Now I am writing this in the cyclic form. Which cyclic form? Number 5. This is my fifth carbon. See the fifth carbon. And this is
Yes, sir.
this is a ring formation between 5 and 6 carbons. So I am showing it like this. Carbon 1 is my CHO.
Yes, sir.
1, 2 carbon, 3 carbon, 4, 5, and fifth OH group. Sixth CH2 remains as it is. Now this is a lone pair of electrons. You can see that lone pair of electrons. Student, that is what attacks this carbon.
Yes, sir.
Hemiacetal formation, student. So what will be happening then? This will become O minus, and once this oxygen, this proton will then transfer at this point. So it will become OH, and this ring will be formed. See the ring formation?
Yes, sir.
This O minus will take this H which is being released, and it will become, once OH, it becomes OH, student, this carbon has got now 4 bonds. It becomes asymmetric carbon. There is an increase in one asymmetric carbon. So if the OH group is on the top, OH group is on the right side, alpha. If OH group is on the left, beta.
Yes, sir.
And when we write the Haworth structure, what we do? Draw a ring. Those which are, students, those groups which are present on the right side go lower.
Okay, sir.
And those which are present on the left go up.
Yes, sir.
OH groups. And then you can write the hydrogens.
Yes, sir.
So there are 2 forms of the glucose which we have shown here, alpha form of glucose and beta form of glucose. Students, this is just to tell you how this I will learn to make Haworth structure. Further important point is a 6-membered ring, students. They can exist in chair and boat forms. This is the chair form of the glucose. Chair form of the glucose, student, where you can see that those atoms which are not shown are hydrogens. So chair form of the glucose. This is oxygen. This is existing in the chair form of the glucose, student. It not required for the paper, but I have tried to show it. The difference between the chair and there is a chair form which can also be drawn from the Haworth structure.
Yes, sir.
So students, I hope you understand that glucose is not existing in open chain only. it will
Yes, sir. Yes, sir. I get it.
it exists in cyclic form, and because certain reactions could not be explained, they will be asked in the paper on what basis the cyclic structure of glucose was proposed, which reactions are those which were not given by the glucose, because of once a CHO group forms cyclic ring, it is not free. Therefore, it will not form sodium bisulphite product. It will not form oxime with hydroxylamine. And we have already told you certain reactions. The pentaacetate of glucose is not reacting with hydroxylamine. Schiff's test is not given. Hydrogen bisulfide product is not formed.
Hmm.
These are the reasons they proposed a cyclic structure of glucose, which was verified experimentally because there were two forms of glucose, alpha and beta. And what are anomers? They differ in the configuration at C1 carbon, students. This question has also been given. All right, then we will meet you in our next class, students. In the second part of the biochemistry, glucose is the most important where question will be asked. So we have spent more time on glucose. Okay? Okay, then we'll see you in the next class.
Okay. Thank you, sir.
Okay, bye bye. Meet you in the next class.